Alright, let's check on the parabola on this vision. Now, parabola this vision, or in the vision of y equals to a into x minus p all squared plus q. Then, to arrive at this situation or this vision, or the completing of the square. But in this case, now let's borrow this p and q are the coordinates of the turning point. So now it means if you have the formula like this already, what you can take from this area turning point. So that one simply by getting the turning points. So remember, we need to sketch. So turning point must be part of it. So rather than validate our turning point here, simply the narrative value then it's kind of solve over x equals to minus 2. So rather we have minus 2 and minus 1. Then of course certain gives the brackets or it will be like x minus x plus 2 equals to 0. Then we put it in brackets then. But remember, in it's on as a vector, then this is the roots. This one, the roots goes to the graph. Right, we'll talk more about the roots on later stage. Then now, after turning points, what can we get? We started by finding turning points. Now number 2, we can find the simplest one, which is the y-intercept. So remember, in y-intercept on the Cartesian plane, so it means in this case the line is to draw cutting there the y-axis. So it means the only line that cuts the y-axis is x equals to t. In that case, t waiting for any value. So it means in here, for it to be the y-intercept, it must cut this line of a y, where we'll say x will be 0. So x will be 0 in that case. So then now it means y equals to 0 plus 2 all squared minus 1. So our y-intercept this will be 4 minus 1. So this will take us to 3. So it means the intercept. So in this case, is 0, which is 0, and then 3. So this is the y-intercept. Now the x-intercept, which is number 3. Then in the x-intercept, so we normally say this is the x cut. So the x cut in this case, it means we must cut the x at the neutral where y equals to 0. Then in that case, it will start by say, okay, 0 equals to x plus 2 squared minus 1. I mean, it's more algebra quadratic or parabola here. So we solve quadratic or whatever. So I'll just take this to other side and have remember, if we require this one to the other side, we'll change the sign. But what we do is that we must add 1 this side and also add 1 on the other side. Maybe you can say 1 like this. So to write it nicely, normally we'll say, okay, we add 1, then that will be 0 plus 1. So that if we add 1 and 1 then this one would add in both sides. So this one will take away this one, then we'll have to 0. Then this side will have 1 equals to x plus 2 all squared. So next time I'll I won't show the adding both sides, but you just say, okay, if we take 1 this side, -1, then when it comes to the other side, it will be +1. So that's what we do. So just learn that so that next time if I do, don't get confused. Right, then we're going to say in this squared saying there must be 2 roots. So meaning if I need to take out this square, then I must say the plus minus the square root of 1 equals to x plus 2. So that's when I take out the square root both sides. Then we need to have this part so that shows the 2 roots. The other one will be positive, the other one will be negative. Then now what is this one? Is plus minus 1 equals to x plus 2. Now we do the same of taking 2 on the other side, but let's separate this. We'll have x plus 2 equals to 1, or x plus 2 equals to minus 1. Then x equals to, now when you take it to the other side like we did here, so we're going to have 1 minus 2. So in this case it means we're going to have x equals to minus 1. Then this one, x equals to minus 1 minus 2. So x equals to minus 3. Then now what we could use again for the x-intercept. So I'll have minus 1 and 0. And then I'll have minus 3 and 0. Now I have my 3 things to draw the graph. X, the intercept, and the turning point. Then now just have this. Right. Now let's start by the intercept. The x-intercept is minus 3. So we can calibrate this to have minus 3 here. Then the other one is minus 1. Oh, on this side, both of them. It's fine. Then now we need to get to the y-intercept. So the y-intercept is 3. If we have, then we have 3 here. Then now, what is left? We need the turning point. So turning point is minus 2. This one is minus 2 and minus 1. So minus 2 and minus 1. So we can have the turning point here. And the graph, and this point and at this point. So it means from the turning point, the shape is like this. It's going to concave up since the value of A is positive. The value of A is positive here. So it's plus 1. It's positive 1 in this case. So now, after the turning point, so the graph must go like this. Then from this turning point, it will go to cut this value here. And then now, this is our graph of y in that case. So quickly, after getting the graph, of course you can write the points. You must write the points. Here is turning point is minus 2 and minus 1. And then the point here is minus 3 and 0. And the point here is minus 1 and 0. Right, from this graph, what you can do next, so you can do the axis of symmetry. The axis of symmetry, the line that is going to pass through the center, that is dividing the graph into 2. So the axis of symmetry, axis of symmetry, so simply be x equals to minus 2. So the graph is divided equally at x equals to minus 2. So can you see I say x equals to minus 2? So because the graph is going to cut the x-axis, then it means must be x equals to. So the equation of this line is x equals to minus 2. So that is the equation of the axis of symmetry. Because the line is going straight, and it means this line is parallel to the y-axis, then it's going to cut the x-axis. That's why the equation is only x equals to. All right, and then we can get the domain. The domain. Now the domain, we agree that is just x, an element of real numbers. Now the range. So range is y. Now because the graph is concave up, so if it's concave up, then we'll say y is greater or equals to from minimum going up to the maximum. So what is the value of y here? Is -1. So it's supposed to be greater or equals to then the value of what? The value of q, which is this one. So it's -1. So that's what we have for the drawing parabola in this form of a into x minus p plus q. So we can get the domain, you can get the range, then you can get the x of symmetry, the x-intercept, the y-intercept, and the turning points.